Welcome to TechDay 2024. My name is Willie Peng. I'm the Associate VP for Academic Technology. To kick off this event is someone who needs no introduction. He has been part of the campus community for many, many years. He knows every inch of the campus, and he knows everyone. This person is everything, everywhere, all at once. And I don't know how he does it. And he's also my mentor, Amir.
Thanks, Willie. Thank you, everyone. Thanks for being here. I'm very excited. As you know, the theme today is AI. You know, since my name starts with A, I always use that. But AI has been really, really important to me for past decade and more. So we had a lot of excitement last semester when we had the Spring AI event. Now this Tech Day is another excitement about AI. You hear about AI every day in your TV, in your radio, everywhere you see. When you see Elon Musk dancing on the stage, you know it's all about AI and everything else that we learn about AI. So today is going to be another fantastic day. We have all a star of presenters, especially our keynotes. We are very thrilled to have him here. Willie will introduce him in a few minutes. But I wanted to, can you go next? I wanted to talk about a couple of things. One, I want to show you a graph about the progression of AI from 1950, when Alan Turing started the artificial intelligence, and all the way up to ChatGPT 4.5 that's coming. You can see the exponential advances in technology with respect to AI. This is very critical. We put together, the Titan Communication and I have been working on a 2.5 to 3 minutes video. So what I like to do is show you that video that sum up everything about AI and his history. So can you play this?
Artificial intelligence. What was once a dream, something out of science fiction, is now everywhere. It all began back in the 1950s with pioneers like British mathematician Alan Turing. He dared to ask a bold question. Can machines think? That simple question started a revolution, one that would change the world.
One of the things that AI has done recently is actually he has created a bigger divide, digital divide with our students and everywhere in our community. As you know, if you go get AI today, you have to pay $20 for ChatGPT. And there's a lot of tools that also charging our students. So I want to, today, switch. I want to introduce Titan GPT. We are going to, thank you. It is coming as actually, the soft launch of Titan GPT would be December of 2024. We're going to soft launch it coming in December of 2024. What is Titan GPT? It's OpenAI Omni that's available to all of our student, faculty, and staff across the board. We are trying to close the digital divide with this tool. We're going to have more tool coming. Also, we will be releasing Dolly to the students coming in the spring. So it's not just, and a series of a tool that comes along with it. Can you switch? So it will be available on ChatGPT 4.0. The Titan GPT will have multimodal, and it will use our single authentication. That means it's secure, it will have privacy and ability for all of our students to enjoy this great tool for our students. So I want to announce it today because I know there's more to come. If you talk, Willie's sessions, we'll talk a little bit more about this. But by default, in December, we'll be releasing the Omni 4.0 ChatGPT available for all the student and faculty staff. And you can be able to log into it from your CSUF accounts. That's coming up. So this is, again, it's very new, and we'll talk about it in more. We're gonna do a lot of things coming up in AI on the campus. I know they give me only 5 to 7 minutes, so I want to make sure that I use my 9 to 10. So what we're going to be doing, we're going to be doing some custom GPTs. We're going to have APIs. We're going to be able to really expand how we're going to use it in the classrooms. How do we look at the curriculum? How are we going to use it as a business? And also, how do we use it across to support infrastructure of a campus? You see a lot of changes coming up in the spring of 2025, and we'll hope to have AI integrated to our campus, very seamlessly across the board.
It is my pleasure to introduce our keynote speaker for CSUF TechDay 2024, Dr. Tom Defanti. With a career spanning several computer generations, Dr. Defanti has been at forefront of computer graphics, virtual reality, and high-performance computing. He's a distinguished professor emeritus of computer science at University of Illinois, Chicago, and also a research scientist at UCSD Qualcomm Institute. His pioneering work has greatly advanced the fields of visualization, interactive technology, earning him many awards and recognitions worldwide. And we are very honored to have him to share his passion in investing in research and education in AI infrastructure. Please join me to welcome Dr. Defanti.
Does the button work? The button worked. The button worked. Hey, new tech for me. There are no AIs harmed by my presentation. This is all mine. So it's really, wow, this is a great audience. I'm really excited to be here. And Amir, you did such a great setup for me because I think people will kind of now be a little bit interested in where a lot of this came from. And, as we look back, my last PhD student in Illinois was doing AI, and we didn't even, he was doing a facial recognition thing because I wanted to be able to do 3D video conferencing. And in order to do that, you had to be able to track people, but you also had to do it without them wearing funny glasses or markers all over the dealy bobbers and stuff. And so he was doing real-time facial recognition. It was so good that we had some folks from the CIA visit, and they would not get in front of it because they didn't want to be recorded and turned into an AI. So that was 25 years ago. And 50 years ago, showing my age, I knew Marvin Minsky. I knew Marvin Minsky for he was one of the fathers of AI. And we always thought that we called a lot of it, we called pattern recognition back then, and speech recognition. And we always thought that was the opposite side of visualization computer graphics. We would generate things, they would recognize things. And I said to him, Marvin, I understand what you're trying to do is create stupid humans, but what is the point? We have plenty of those. And I had completely missed it on two dimensions. One is that they were going to get really smart, but the other is that you can do a lot with a huge number of stupid humans. I mean, if you have trillions of stupid humans at your fingertips, you can do a lot. So that's really a gap, that's different from, and I'd missed that completely because I was making pictures and doing video games and stuff like that. So let me go on. So this is a thing which I find to be exactly at the point of what we're doing here today. And this is not mine. This is from a place called mindsweneed.org. And it's about why are we doing this? And it's because we really want to connect all the universities and all the colleges and all the libraries and even the K through 12s are working with now, and the ones that are chronically underserved, some of the tribal colleges and universities that are, they're not on the mountaintops, so getting them internet was tough, right? This is something we've been doing in California for a long time, and this is really important. We want to get every student and researcher everywhere the best tools, and because we don't know where the next geniuses are going to pop out. And we want to ensure, of course, our American competitiveness and leadership. So that's really the overall goal. But then as we dig into it, I want to tell you about, so one day a week I work for CENIC. CENIC is California's network for education. Most of you don't know what CENIC is because it works. When it doesn't work, you know what it is. But when it works, it's just great. It connects everybody. It does it in a way that is so much better than any other state or any other nation in the world. And it's been around for more than 25 years. It connects every K through 12 community college, California State University, University of California, private universities, public libraries, and museums. Not all the museums, not all the public libraries, but it's getting there. And there is a new project that's complementary to this called the Golden State Network, which is a $7 billion project. That's a lot of money. And that's going to connect everybody. That's putting in the fiber everywhere. So 2015, so this is like 9 years ago, we decided that we wanted to connect the universities and solve a problem that they were not able to transfer data quickly, and it's because of the design of the internet was really not designed for high-speed, large transfers of data. For those of you who know what TCP is, it's all TCP's fault. And so we got a grant from NSF and I started building the Pacific Research Platform. And it connected all the universities, the campuses of the University of California. And the idea there was to be able to move data and to solve the problem. We used technology that ESNet had developed, but then we expanded it. So we built these nodes, these things, and you have one of them here. And you've got a whole boxes and racks of them now. But as part of your Triton, as part of your GPT. I'm sorry, it's Titan GPT. Right?
Titan GPT.
Thank you. We're the Tritons, you're the Titans. You know, so these things have 4 to 16 of these NVIDIA GPUs. And I started building these 8 years ago. I started building them out of game GPUs because I know how to do things like this. And this was completely counter to what everybody else was doing. They were cheap, relatively cheap, and we stuck them in racks, and they scream. They really make a lot of noise because you have to run the fans.
Want to come to you screaming
Yeah.
server room, please let me.
Yeah, it's actually painful. The reason why we had to do that, I found out the other day finally, is that you can monitor the heat of the CPUs and drive the fans faster. The fan thing doesn't listen to the GPUs. So if you've got something that's not using much CPU but a lot of GPU, it'll overheat. So we just have the fans going all the time. So in any event, this really got us so we could start using these networks over long distance at 10, 40, and 100 gigabit networks. So then at the same time, our UCSD IT services built a similar system called the Data Science Machine Learning Platform. And this was good because the characters that I worked with, I didn't believe they were going to be able to pull this off. And then Adam Tillman replicated it and immediately was serving thousands of students. I go, okay, I think it's going to work because if students can't break it, it's bulletproof. So we started putting all the software on it, and this was a student-focused platform. So this was in 2018. This was six years ago, right? And it's managed by IT services. It's used in over 60 courses every year by more than 9,000 individual students for 20,000 labs. So obviously, a lot of students take more than one lab. That's a lot. You know, it also gives me complete confidence we can expand this for, working with the CSUs to 100,000 students. I think we can do that. These are courses. I'm not going to read through them, but there's a lot of different courses, and they're all very AI-oriented because all these GPU nodes were AI-focused. And what that really means for you is that there's high-performance computing nodes, which are 64-bit floating point, and there are game computing nodes, or ones that are similar to that for AI. They only need 32-bit. Actually, you can do AI with 16-bit or 8-bit, and some people even do it with 2-bit computing, amazingly enough. But you don't need the 64-bit, and it makes things a lot cheaper. So we put a bunch of these things in the back of my Highlander, and we took one to Stanford and one to Santa Cruz. I like to drive. Went to Santa Barbara, went to UC Merced, went to Irvine, and went to Riverside. And we plugged them in, and they're screaming there still. So that was the first phase. And then in last year, we said, okay, we're going national. And we went from the Pacific Research Platform. It was originally a Pacific Research Platform because nobody believed we could do a national scale program. So we had to prove it first. So then the National Research Platform happened. And we've been having conferences about it. And then this time, a few of them I drove around, but most of them, there you are. And most of them, actually, you drove, you picked the one at my house. Yeah. And San Diego Community College District is our first community college district, and I expect them to be replicated now in the LA Community College District and the Los Rios, I believe it's called, in Sacramento, and then other ones will catch on. This is really important, by the way, because the CCCs feed into the CSUs, and an extremely important part of that, much more even than the UCs, the extremely important part of that is you want the curriculum and the tools that people have to actually feed into it. You don't want people to get here and they say, well, you know, you don't know anything, take all these other courses and lose a year. You want them to be able to smoothly go in. And so there is a concentrated effort at UCSD with San Diego State, and Berkeley's working with Northern California universities. And we want to work with you guys on this too to make sure that what the CCCs are doing, the LA Community College District is coming on strong with this as well. So I think this is a good place to get together, and it's new, it's fresh, so we can do it. We can try to do it right, you know. SDSU built a cluster called Vern, and this is for their instruction, and they federated this with the NRP. Actually, he just joined its Nautilus, and it's a substantial system. And so I'm showing you some of the models here for people and to kind of compare yourselves with, and I tell you, you compare really favorably here at Fullerton now. And the Professor David Goldberg there did an AI survey last spring, and I know you guys have done one here, and I'm hoping to hear about what your results are. But the interesting part about this was they got really good student response rate for a survey, because you know we all get surveys and we just ignore them, but this one actually got 21%. And they found out that 59% of the students said they use AI in some capacity, that 52% expressed interest in receiving formal training on AI, 45% use ChatGPT, 41% use Grammarly, and 28% report that they're currently offered adequate AI training opportunities. So, but the most important thing that we want to hear as teachers is that the students think that what we're teaching them will play a significant role in their career. That's really important, because otherwise we're just making them take courses to graduate. So the SDSU AI survey has been replicated in a bunch of different places, and they're making it free and available, and we know that you guys have so this slide was from last summer, and you've already jumped on it, so that's great. At San Bernardino, one of the early ones to work with us, they teach courses on the National Research Platform. They're a little bit broader. They don't have quite as many AI courses, but they do have a lot of AI and ML projects. So again, just to show you that you're in good company here. Now, last summer, I asked Kendra if, I think it was last summer, right? I asked Kendra if we couldn't try and find out who's got free rack space, because one of the things that we're out of rack space at UCSD. We just don't have any place to stuff anything anymore. Our chancellor's willing to loan us the money for more rack space, but then he wants us to charge us for it, and that gets expensive. So it's too expensive. It's not my budget, you know. So I wanted to know who's got rack space, and so that we can send systems around and plug them in and get things started. And so this is Kendra Willie and Dusty did this, and Mike Farley from SDSU. And this is important because having racks available for this kind of thing is what you need. It's really what you need. Oh, look at this. Look at this. Look what I stole. This is off your web. I took things off your website and made this slide up yesterday. And Dusty sent me this picture. So this, I guess, you're going to show this to people today? They're going to be able to see it? I think I'll go in the room and listen to it scream? Yeah. Okay, good. So this is terrific. And so one of the things that we do is we help people manage, essentially run the operations of this connected cluster called Nautilus. And this is now a big piece of it. This is a very substantial chunk of it. And everybody always says to us, well, how do I know if I join your thing that I'm going to be able to get at least out of it what I put into it? Well, it's actually very easy because everybody doesn't use their resources uniformly. And so when you want it, you can usually get a lot more. And if you feel like you're not, or you have a special project coming up, the Kubernetes system that Google developed that we use allows you to very easily fence things off. It only takes a few seconds, and you can fence off things for periods of time or permanently if you need to, but it's very manageable, and you can mix back and forth, deciding on what your instructional loads are and so on. Important thing here is the storage. Very good, Willie. Good job on the storage. So here's the San Diego Community College District. They got rid of their big IBM mainframe and have this gorgeous computer room. It's the size of this that's almost empty. And so we want to get that filled up. We brought it down there, plugged it in, and it was up running in 15 minutes. It was amazing. It was the fastest install I've ever done. Okay, so here's what it looks like now in the state of California. And I point out two WOW systems, the one here and the one at San Diego State, because the two of them together have more CPUs and GPUs than all of the rest of the state except for UC San Diego in Nautilus. So this is really something. I mean, this is all in the past year. So.
Tom, can you say what is infrastructure from the user perspective, what does it bring? And what does this do for everyone from the educational community?
Okay, let me get to that in a minute, okay? And I will answer that question. Well, in a sense, here's what it gets you. So if you're on this system, if you're either using it via a Jupyter Lab or via your own a namespace, which is what we call projects. Once you can use all the systems within California, the scenic airport, and so that's substantial. You can see it's 800-900 GPUs, thousands of CPUs. But once you run out of that, or you find something that's special in another place, there are ones that are connected in there, and then there's all these other ones. A huge amount of activity in the Midwest now, and in Missouri and northern up to University of Nebraska, and then a variety of ones on the East Coast. So these are all substantial systems that are all connected. Generally speaking, as a user, you don't know where you're actually commuting. It doesn't matter to you unless you have a specific data source that you want to be next to or a shared file that you're working with somebody on, then you can specify where you want to be. But generally speaking, you don't care. And that's really good because these systems do go up and down. A lot of them are game GPUs, and a lot of them do just go, I quit, And so, and the software just says, well, forget about you until we get somebody to go over and push a button if we can't do it remotely. So it's really nice that you're not tied down to any one place. We have unbelievable amounts of data collecting we know what you're doing. We know how much time you're using. We know where you're doing it. We know all this stuff. And and people often want to know that. The whole idea is to get students and researchers ready using clouds, whether they're commercial clouds or Nautilus is a community-owned and operated cloud, right? I call it potluck supercomputing because it always reminded me of when you go and do a potluck, luncheon at a church or something like that, and everybody brings food, and usually there's way too much, which is great, but you get a whole big pile of food, and you only have to put one thing in, and you get to taste all these different things. And we also have a version of it called Soup Kitchen Supercomputing for people who can't bring any food because they don't have any. That's we don't couple people, campuses providing resources to people using it. So everybody who's at a nonprofit institution can use Nautilus right now, and with the idea that we'd like them to add pieces to it, but you don't have to add pieces first. So there are chickens and eggs, but they're not connected. We have user applications, and they go into things called containers. What the containers do is isolate whatever thing you're doing from destroying the machine you're on, which students are really good at. I was one once. We liked doing that. It was, your prowess, if you could bring the machine down. Confuse the IBM mainframe. We used to do that all the time. And then Kubernetes is an orchestration system. It says where to run these containers. And by the way, Kubernetes was developed by Google and then given away. The whole idea was that when Google started, they were just building PCs out of junk, literally building out of junk. And so they had to have a way of dealing with things that were not all the same, like most HPC systems are one monolith of identical machines, and when they get old enough, they get out they do what's called a forklift upgrade. They take it out to the loading dock and dump it. But Google didn't do that. They wanted something to deal with extremely heterogeneous systems all over the place. In other words, separated. So this is not a normal HPC cluster. And then you either go to the National Research Platform, or there are commercial clouds that there's a variety of things like CloudBank that help you get to that. Now, one of the really cool things is that what are you going to do? What do people want to do with computers? They really want to get at data. They want to take data. They want to analyze it. This is what AI is doing for us as scientists and researchers, artists, or whatever, is taking AI, is taking data and making sense of it, making it, try to understand it. So where do you get all this data from? And the problem with data historically is that you go to some place and they go, yeah, well, we have these data things, these data products, they call them, and it works with a certain this and that and the other thing. Oh, you don't have that. Well, we can't help you. And, or you have to write programs to do it. Well, the National Data Platform is set up. It is actually built on top of NRP. The PI of that was co-PI of the NRP. And right now, as of when I pulled this out a few days ago, they have 5,100 data collections and live streams, and they're just starting to build up users. So I hope you guys jump on it and really use this. But it is a way of getting at data for courses and for research. So here's a fellow who really uses a lot of this up at Northridge, Bing Lee, and I'm not going to talk about what he's doing, but he is just tearing a hole through our machines. He's using a lot of time and publishing like crazy and getting grants, and so he's a good model. You should invite him here to talk about how he's being successful. SDSU, San Diego State, is the lead campus for this new technology infrastructure called TIDE. They got a big NSF grant and had Northridge and Humboldt, Cal Poly Humboldt, and Channel Islands and Stanislaus, and what's the one there I can't read? San Marcos, okay. And as a resource, so NSF has these various grant types, and I'll talk about them in a second. But this is something with $800K for new computational core and $200K to help onboard, to do courses to help onboard teachers and users. And it's federated, it's part of Nautilus. And so it was our first new NSF resource on Scenic Air. Scenic Air, by the way, is really what the PRP turned into, and the reason why we put Scenic into the name of it was because Scenic offered engineering services to the campuses and network engineering services and also communication services. They have great communications people. And I don't have either of those to give away. And so this is really great that they stepped in, and they've helped a bunch of campuses develop their networking in a way that they can take advantage of Nautilus. It's not trivial, and it wasn't even easy for them to figure it out in a way that wasn't idiosyncratic for every campus. So they now have a method to do that. There's the SDSU box. And Jerry Sheen got the 2024 Scenic Innovations in Networking Award for kicking this off. So Jupyter Hubs. So Jupyter Hub is the easy button. This is the way that you build a little framework for your students, for your research, that essentially has all the parts and you just edit and plunk new pieces in. Right? And it's a very contained system. It can get up to 8 GPUs, which is a lot of compute power. We run one standard one for everybody that we support, but 50 campuses have made more than 100 of their own Jupyter Hubs in Nautilus, and they have over 1,000 users. You've got one, right? Yeah. So Cal State San Bernardino has one. And they use CI logon, which is the same thing you do. It's all the right thing to do. It gives you the kind of security you want and what we need. And they've been increasing users by quite a lot. So San Diego State, the San Diego Supercomputer Center at UCSD and the NRP are working together with the San Diego Community College District to create a common San Diego instructional Jupyter Hub. Remember, we're trying to get away that the community colleges can feed into the state universities and to the UCs smoothly. My older son took 8 years to go through college, and 3 of those years had to do with the mismatch between his community college and his four-year college at SDSC, and they just kept screwing stuff up. And I complained, and they said, well, don't complain to us, complain to your legislature because we're underfunded. All right, well, I understand that. But in any event, in this way, we're going to try and get it straight. So what are our strategies for the next 2 years? How much time do I have left? Just give me time. Oh, then I'll have time for questions for sure, because I'm almost done. So we're focusing on growth. And growth, there's wonderful things about growth. As long as things are expanding, you can make them free. You don't have to have as many rules. It's when things start to stabilize or flatten out that you have to start pushing policies and allocations and everything else. So far we don't have to do that. And the growth is coming because of more science DMZs. These are the areas that you put these computers and allow them to connect together at high speed, and with the Scenic Air engineers. Developing joint compute and storage capacity in people's empty rack spaces, which is what I mentioned before. That's really a key thing, is to have places we can put this stuff. Because building computer rooms or renting computer rooms is very, very expensive. And then to seek AI education content development funding opportunities. So there's lots of people building these things. I have a proposal in to fund, nationwide fund the development of applications for students and more of these Jupyter Hubs. Jupyter Hub, by the way, comes out of Berkeley, and it's a brilliant thing that they've developed and given away. and then to encourage campus and government investments in faculty and facilities. We have a meeting coming up on January 28th through 30th called the 6NRP in San Diego, and I hope some of you can come to that. It'll be mainly for the folks like Willie and Dusty and the people they work for and the people who work with them, and to really get together and learn what the next steps of this is and who's going to use it. One of the things that's been really amazing is that NSF has changed with these cyber infrastructure programs. I've been getting NSF grants since been funded by NSF since I was a graduate student at Ohio State in 1969. So I actually really do know everything there is to know about NSF. The one thing that's amazing is that until about a year ago, maybe it's 2 years ago, they didn't fund anything with undergraduate education. It was all for graduate education, graduate computer science, graduate science. There was a certain amount of things you could do for studying how undergraduates learned, but nothing to support undergraduate labs. They always considered that to be part of the university's problem. It changed. Now they will give you money to support, and substantial amounts of money to support undergraduate class labs and research opportunities. And so they have 2 deadlines for these every April and October, and they've expanded this to 5 different areas. The last one is kind of a planning area, but there's ones for storage, there's one for integrating your networks, there's ones for buying computers, and there's ones for the data-driven side of networking. These are they also used to say, if you ever got one, you could never get one again. And so we got one to build the original version of this, maybe 2005, 2006. And they said, well, you can't ever apply for another one. Go, well, but stuff is old and dead and gone. They go, we don't care. Now they allow you to apply for essentially all of these, and in sequence or in any order. And that's also a big change. I mean, it really is a massive expansion. The other thing I will tell you is that if you look at that map up there, you'll notice that it's awfully concentrated on the East Coast and the Midwest. And the program officers say, how come people in California don't ask for this money? Why aren't you doing this? So they really, it used to be that they would say, well, we can't give all the money to California and to Illinois, because the supercomputer centers were. We can't give them all. You're not going to give you any more money. You've got to get to other places. But now they're coming back and saying, where's with California? Why aren't they? So Willie and Dusty and Kendra, and I'm sure you're getting pulled into this, and are really going to work on getting one of these things for you guys and your. To build up your infrastructure here. The other thing that's happened is this thing called the NAIRR. This is the National AI Research Resource. When I named Scenic Air, I left out the second R because I wanted it to be a resource and not just a research resource, right? I want it to be for education too. And after the head of this, Katie Antipas, came to our campus and saw what we were doing, she says, well, we need an education part of it too. And so there's an NAIRR classroom. But they are, it's interesting because our opinion, this is really Frank Werthwein's words, but their idea is to essentially just set up classrooms and or give a really cloud resource allocations when you get down to it. And we want people to build their own thing. And so Frank says it's like the story about giving a person a fish and you feed them for a day, you teach them how to fish, they feed them for a lifetime. So I'm saying here, this is me, go CSU fishers, right? I know you're not fishers, you're Titans, but anyway. But you can, this is another way of getting money and to go after or at least resources at this point, access to resources that should not be ignored. They did give San Diego Supercomputer Center, I don't know if we've actually got it yet, I think we've gotten a grant to make some of our, it might even just be an unfunded mandate, but to make a substantial number of our A10 processors available for educational users. So here's places where I see our success happening now is to expand Scenic Air via these CC star solicitations with you guys. And like I said, they're expecting us in Washington to submit these things, and we're happy to help with the forms and contents. NSF grant proposals are really annoying in terms of the amount of paperwork. You get 15 pages to do the project, and there's 100 pages, 150 pages of boilerplate, of the most amazing things that all have to be perfect or they reject your grant. And it's enough to make anyone, every time I do one of these, I actually hate myself because they're so hard. There are people who are good at it though, and so we've been introducing our folks who are good at it to get collaborations. With the Nair Classroom, we can lead with that. And we've already developed, devoted resources for educators' proposals into NSF. We want to bring more data science innovations to instructional practice, to open the Data Science Federation, integration with PyTorch, and to have the national data platform share content, and reduce the cost of inferencing. So then artificial intelligence, this training, which is what everybody talks about, where you need 10,000 GPUs, but the real users of it do what's called inference. So the training of it is basically the equivalent of building filters, and the inference is running things through filters. And it's incredibly imbalanced. It's about the equivalent between making a movie and watching a movie in terms of effort, or designing a car through production and then buying one to drive it. I mean, it's really way imbalanced, which is good. But the problem is we've been using the computers for the training, also for inference. And this is now changing. People are coming out with boards that are way cheaper, and that can be used for inference, and also for a thing called fine-tuning, which is a way of making it work for your data sets, not just for the data sets that the people with the LLMs have. And we need students to learn this and become the workforce. So I want to just tell you what keeps us going is that we know that we're going to have growth in users and growth in institutional leadership, wanting to service people, especially under-resourced places, and the growth in these science DMZs because the Scenic Air people are making it an easier thing to do. In other words, the network part of it, the advanced networking part of it. And we know that the community will support user and classroom instruction and training the trainers because universities have, like class labs, and they have funding mechanisms through tuition and stuff for that. So that's a no-brainer. It's just pushing towards where the demand is. The Jupyter Hub development will go on and continue expanding. It is the easy button. We have social networking with our Matrix chat channel, and a lot of people use that to support each other. And we have multi-institution student projects because the collaborations are made easy. It's very easy to work with people on other campuses. Now, but what keeps us up at night? So I worry about this stuff. And because we do have a free resource, and that of course is normally an impossible thing to pull off. What do we worry about? What do I worry about? So can we keep growing? Can we keep up with the growth in use? How many GPUs should we have a year from now? How many of these GPUs or arithmetic processing units should we add? Can we increase the staff to deal with this growth? Right now we run Nautilus off a very, very thin staff, and we need to get more funding, get more staff, or get more cooperation. So I'm talking to Willie about cooperating with our operations people so that we can offer more than 8x5 operations. I don't think 8x5 operations is enough for instructional labs. I think we really have to have something. Thank you. And are we prepared for changes in the AI workflows? The AI has changed several times in the past few years. And the equipment that's being used for it has gone completely wacko, where people are literally Oracle, Elon Musk, 10,000 GPUs, right, in one place to do something. And are we obsolete? Are we getting just completely run out of business? I don't think so. I think that we are seeing the workflows change, but we have to lead that or chase it and do both at the same time. I worry a lot about storage because storage is forever. Computing is transient, but storage is forever, and people don't behave well with storage. Security and resiliency is always an issue. So those are things that worry me. So we're not, it's not all Pollyanna here. Okay, so here we are, I'm done. We need to collectively innovate on the educational content and train the trainers. We need to make that content available according to FAIR principles, which are findable, accessible, interoperable, and reusable. Somebody came up with that. And we need to allow educators to assemble the courses from open source bits and pieces via the National Data Platform, and allow students to get data through the Open Science Data Federation, which they can get through NRP. We can bridge from AI education to application of AI to research. Students are really the lab rats that we need to do research, and they learn this stuff, and the best ones go off and form companies and then give money back to the university eventually. But in the transition, we need students who can do the work, because any of you who are researchers really know, especially in the computing field, that it's students who do all the work, and we just write the grant proposals. So with that, I just want to say that we have a very ambitious vision. We're horizontally open, we're vertically open, and we understand how we need specialized computing for AI, because AI is an experimental science. It really is. It's really an experimental science. And I have a whole argument about that. I'll tell you if anybody asks me why I believe that's true. But NRP itself is owned and built by the community for the community, and we're looking for new owners and new partners. So that's it. We have our workshop on January 20th to 30th at UCSD. If you go to the nrp.ai website, you can already register. I'm the program chair, but I haven't posted the program yet because it's not finished. And we get a lot of money, and gotten a lot of money over the years from NSF, and this is a mandatory acknowledgement slide. So I am ready for questions. Yeah, please use the microphone because this is being recorded. Thank you. You've been a lovely audience. You've laughed at my jokes.
Thank you so much for your presentation. It's really enlightening and just makes you think about a ton of things you could do with this platform and all the work you've done in investing in the infrastructure and all. From a computer science background, I had a question. I work on Willie's team, and I had a question about, so we're so used to the traditional way of doing computing, and you have this platform. What is the kind of is our languages or infrastructure kind of places to start? Like, are there certain languages that are just best for this GPU world? And is there any, you were talking about the very end about best practices, and or I was thinking there should be some best practices that start because of the concern about all that storage that people could just hog and that not meaning to. And then I have one other question is like, what do you do with your data sets, the results, to keep them, Okay.
Okay, so let me start with that one. So the data systems that we provide, generally speaking, are for sharing. And so if you're not using them, we ask you to put them someplace else. We also don't guarantee them because it takes you AAA minus space if you really want to do a totally backed up system. So we expect people to be able to not use our storage as archival storage. So what that basically means is you download your results to the cloud someplace or to your own PC. I mean, my PC's got a lot of storage on it. I've got a NAS with a pile of storage. So that's a fairly straightforward thing. If you're talking about hundreds of terabytes, then you need to buy your own storage server. But 200 terabytes of storage server right now is about $15,000. It's not an outrageous amount of money, and that's a lot. I mean, 200 terabytes is a lot of storage. So I think the storage is manageable. I think that certainly Willie's got the storage that you guys can use people can use here for more permanent storage. You really want to put things in a variety of places. You can take your storage and throw it into Amazon Glacier for free, hoping that you never need it. You use that for backup. If you need it, they're going to charge you. Right. So that's, and it takes a while. So there are a variety of structures. In terms of how you access all this, how you get it started, the Jupyter Hubs are the way to do it. They give you a whole little framework that you add things to that is just kind of guaranteed to run end to end. You put different things in. You program in Python, PyTorch, these things that are very application oriented, and that's how you get started. And that's, I think, most users who are not computer scientists trying to develop new technology in the area, most of the people using it are using it essentially to look at data and to get insights into the data.
Right. Thank you.
Did I answer all your questions?
Thank you. That's good enough.
Okay.
I just want to, first of all, thanks, Tom. A great presentation. Thanks for his insight and his vision to really build this infrastructure. If you look at artificial intelligence, then GPUs is very, very expensive. If every campus wants to do this, is millions of dollars to be able to process and research using AI. All these GPU everybody talks about, saw it on a video, Tom has been talking about it. It's the need of our researcher to really research in AI. What this infrastructure allows us to do as educational community is to enable us to use a vast amount of GPU at almost no cost. So this is the great work of the work Tom and everybody has been working on for many, many years. And this computing facility is now also available to our campus moving forward. And as Tom talked about it, there is a lot of work's going to be done. The problem is the work is going to expand so fast. AI is growing really fast. So I understand why Tom is not sleeping at nights, because as the growth goes exponentially, the infrastructures, how do we sustain the infrastructure to continue being this high availability for our researcher moving forward? Our computer science departments have reached us about a couple of years ago. How do we do more research in machine learning and AI? How many GPUs can you give us? And we have some locally, but it's very limited. And has the ability to have all these screaming GPUs, right, Tom? Screaming GPUs available for all of us, and the campus community is huge. So I want to thank Tom and all the work that the consortium has done to make this available for educational communities, because otherwise we cannot afford to do this by ourselves. And the consortium and NSF has been inspirational to really make that available, and a growth of, so when you see that exponential on the AI, all the great work, all of those have to be on shoulders of a lot of people in educational community, and those works has been done using, some of the works has been done using the infrastructures that we have been doing for the last 10 to 15 years.
Yeah. Well, I'm sure a lot of it comes from the top down making things easier, but I met Willie and Dusty less than 9 months ago at CENA conference, and they heard what we were doing, and the next thing I know is, poof, you've got the second biggest system in the CSUs, and absolutely amazing, absolutely amazing, and with all the right, with just everything right. So congratulations.
Thank you. Thank you very much. Remember, we never walk at Fullerton. We run at Fullerton.
This is all with Amir's help. So.
Yeah.
And thank you, everyone. Thank you. Thank Tom again. Willie, do you have? No, thank you.